In this part of my lecture, I will show how to conduct a process capability study and a gauge R&R study by using Minitab. Let's consider the bursting strength of glass containers for the process capability analysis. In this worksheet, I entered the data for you. We have 20 samples, each sample consisting of 5 observations. So basically, we have subgroups of size 5. A total of 100 observations are used for this study. And let me show how to conduct the process capability study. We go to Stat again. We go to Quality Tools. Here you see the capability analysis. With the capability analysis, we will select the normal. Here, we can enter the data into different formats. We can consider a single column where we also indicate the subgroup sizes, or we can enter the data as subgroups across rows of columns. I already entered the data in subgroups, so I will select the second choice. And here I will select the columns 2 to 6, representing the 5 measurements taken from this process in each subgroup. Let me select that. Now, you can define a specification limit for the process. In the bursting strength example of glass containers, we have only a lower specification limit, which is 200. We can either enter that, or we can simply not write anything and see what's happening without writing a spec limit. Let me show you some other information from the options of the Minitab. We can transform the data. Here we will assume that the data is normal distributed. So if the data is not normal distributed, you can check, or you can consider some data transformations such as Box-Cox power transformation or Johnson transformation. We will first assume that the data is normal distributed. So I will select the default, which is no transformation. We can have alternative methods to estimate the parameters. Since we have subgroups, we can consider R-bar chart, R-S-chart, S-bar, R-bar, S-bar, or pool standard deviation, and we can either consider an unbiased constant, or we can say no biasing constant. If we have subgroups that have a sample size of 1, we can consider alternative methods to estimate the parameters. In this example, I will consider R-bar method, and I will also consider the unbiasing constant. We have several options. For example, we can display the information in terms of parts per million or percentages. We can perform analysis within subgroups or overall analysis. We can add a target value here if you would like to have the CPM value to be calculated. And we can have capability statistics as given here. In addition, we can also have confidence intervals calculated here, so I tick that. The confidence intervals can either be two-sided or one-sided, such as upper or lower-sided confidence intervals. In terms of storage, if you would like to obtain some values for feature use, you can tick the ones that you would like to store. For now, I will not store any information. Let me click OK. As you can see, since we didn't enter a specification limit, we got a warning. So here I will enter the lower specification limit, which is 200. In this example, we only have a lower specification limit. Let's click OK, and you see the capability output of the Minitab. Here you can see that we hit a normal distribution to the data. Normal distribution is looking okay in this case. So we don't consider the transformation, normal transformation of observations. We have the lower specification limit shown here. We have some information. Lower specification limit is set as 200. We don't have a target value defined. We don't have an upper specification limit defined. The sample mean from this process is 264. We have sample of 100 observations. Standard deviation within the samples is 33.23, and standard deviation overall is close to this value, which is 32.09 or 32.1. We have some values calculated. We have the CPL value calculated. We have a one-sided limit here, so only CP lower is calculated, which is 0.64 as can be seen. CPU is not calculated. CPK is again 0.64 in this case. We have other calculations as can be seen here and some percentage values calculated here. Now, we know that we can consider the process standard deviation is 32 and the sample mean is 264. I can also do some probability calculations based on this information. Assuming that the distribution is normal, let me show you how to calculate probabilities. We need to go to calculate. We can go to probability distributions. We can select the normal here. So I already entered the data for you. The mean is entered as 264. Standard deviation is entered as 32 here. Now, let's calculate the probability that the bursting strengths are less than 200, which is our lower specification limit. I already entered the data for you. So we select the cumulative probability. And let's see what is the probability here. As can be seen here, the bursting strengths, the probability of the bursting strengths to be less than 200 is 0.02275, or we can say that out of 1 million, we would expect about 22,800 glass containers to have a bursting strength that is less than 200. So this is just an estimation. Now, let me show you how to do the gauge R&R study. For this purpose, let me open the next file that I already created for you. Now we will consider the thermal impedance measurements, where we have 10 parts. We have 3 inspectors, and each part is inspected by one of the inspectors 3 times. Each of the inspectors by 3 times. I already entered the data, but let me show how we can enter the data, or how you can create a worksheet for this purpose. Again, we go to Start, we go to Quality Tools. This time we go to Gauge Study. Here you see the Create Gauge R&R Study worksheet. Let me select that one for you. As can be seen, we can define the number of parts. In our example, it was 10. Number of operators, it was 3 in our case. And now at the bottom, we can consider the number of replicates each part is measured by each operator. So this can be 1, or this can be 2. Let's make 3. In our case, we had 3 replicates, so each operator measured each part 3 times. So let's see. 1 minute. Let me show you also the options. Here we have the option to not randomize, or we also have options to randomize all runs, or we can randomize runs within operators. Now I selected randomize runs within operators. So it will provide me a worksheet that will have all the information that is needed for the study. Now, this is the worksheet. simply we have the run orders here, we have the parts, we have the operators. So you randomize, we have the randomized parts here, and giving these randomized parts to operators, you can have the measurement study, and you can simply write measurements here and fill this form to do the analysis. Now assume that we completed the study, we filled the data set, we have the worksheet full of data, and let's do the analysis. For this purpose, we go to start again, quality tools, capability analysis, gauge study, and this time we select gauge R&R study cost. You also see gauge R&R study nested. This is for the case where we have destructive testing or where each operator measures the part only once. So in this case, we have replication. I will select the cost case. We enter the part numbers here. So part numbers is entered, inspectors entered here. We have the measurement data entered here. We have two options. You can either use ANOVA method or the X-R option. ANOVA is more accurate because it has the reproducibility component decomposed into two parts, operator and part operator interaction. So I will select the ANOVA option. Here you can enter the information about the gauge or the study, like the gauge name, date of the study, reported by gauge tolerance and miscellaneous information can be entered here. We have several options. You can enter the spec limits here. You can also include confidence intervals. And again, you can store some of the information that you need for future reference. Let me select this one and press OK. You see we have a plot that is very informative. Here we have the components of variation, basically gauge R&R and part-to-part variation. And here we have the decomposition due to repeatability and reproducibility. We have the percentages given here. And if you want to have the value of the percentages, you can simply go on the value of the value. We have the decomposition, measurements by parts. We have 10 parts, and for each part, we have the measurements. We have the measurements by inspectors, so you see the variation due to the inspectors. So this is inspector 1, this is inspector 2, this is inspector 3. We have the part by inspector interaction plus here. We have the R chart and the X bar chart for the inspectors. To see the difference between the inspectors. And this is the study. Now we also have some information in the session window here. For example, with the gauge R&R study, we have the percent contribution of each part, like repeatable and reproducible components. And here on the top, we have the ANOVA table. Here we can see the contributions or the significance of the part inspector and part by inspector variation. So we have the ANOVA table provided to us. We have the percent contributions, we have the confidence intervals, and this detailed study can be analyzed to have an idea about the process capability. Okay,